Dr. Lim, you unmute.
All right, good afternoon, everyone, and welcome to our talk. Thank you for joining us today. My name is Po Im from University Tunku Abdul Rahman, Utah, and I will be your moderator. Today's talk is first of a series of talks organized by Utah and also PAM, and supported by Malaysian Architecture Student Society and Malaysian Bamboo Society. The talks are planned in conjunction with our ongoing national level Guangdong, Hong Kong, Macau, Greater Bay Area ASEAN International Bamboo Design Competition. And the competition information has also been shared on PAM website and Facebook. So today we are very honored to have with us an award-winning architect, Dr. Eleena Jamil from Eleena Jamil Architecture as our guest speaker. We all know Eleena from her many playful creations using bamboo. To name just a few, the bamboo classroom in the Philippines, the bamboo pavilion in KL Botanical Gardens, bamboo terrace homes, and many more. So Dr. Eleena received her tertiary education, including a PhD from the Welsh School of Architecture, Cardiff University. She started her practice in 2005, and her portfolio has since spread across many parts in Southeast Asia. She and her team were also shortlisted for numerous awards, such as the Dezin Award, World Architecture Festival Award, the Leaf Award, and the American Architecture Prize. She is a firm believer in research-based, design-led architecture, exploring the experiential potentials of form, material, and construction with emphasis on sustainability. Our talk will take around 30 to 45 minutes, and you can reserve your questions to the end. If you have, if you wish to type your questions on the chat room, you may also do so. So let us welcome Eleena to share with us on the topic, bamboo as building material. Dr. Eleena, the floor is yours.
Thank you, Dr. Lim. I would just like to check if everyone can hear me. Yes?
Yes.
Okay, great.
Yes.
Thank you, Dr. Lim, for the introduction, and hello, everyone, for tuning in, taking time to listen to me this afternoon. So I understand that there is a lineup of 7 speakers, and I'm the first one. So my talk today will focus more on giving an introduction on bamboo as a building material. So it will be less about my work, but more of this amazing material. So the focus will be more on bamboo in its most natural form, meaning in the form of whole cones or maybe split or flattened without having gone through any technological processes such as laminating. So bamboo that is still recognizable in its natural state, which is the focus of this talk today. So I'm trying to change my slide. Okay. Bamboo is a building material that is grown by nature. So there is no other building material in the world where you could just harvest and then treat it and use it immediately as a building material. Therefore, it is a great sustainable material as the embodied energy is low, and especially if you use it locally. Materials like timber, steel, and concrete will consume a lot of energy in their production process to make them usable as a construction material, but not for bamboo. So this is important because the construction industry forms one of the largest consumers of resources and energy, and has also been recognized as being responsible for a huge proportion of waste and CO2 emissions. For example, buildings and construction now account for 39% of energy-related carbon emissions, 28% coming from buildings and 11% coming from the construction industry. So the impact of what we do as architects, developers, contractors on carbon emissions are really huge. So what's happening now is that the extreme climate change that we are experiencing now means that there is a need to shift in the way we build our environment. And I believe that using more renewable and biodegradable resources like bamboo will really help in kind of reducing emissions and lessening the production of waste that we are experiencing right now. So as an architect, I feel that bamboo offers architects and designers kind of the opportunity to build more sustainably as part of the civic duty to overcome the effects of global warming and excessive waste. So bamboo thrives in many parts of the world, so there is no shortage of the material or finding places to cultivate bamboo. For example, you get the Guada angustifolia, which thrives in South America. In Asia, you get the in South Asia, you get the Dendrocalamus asper and Bamboo sublumina, very, very strong bamboo. And in China, you get the Moso bamboo. So bamboo, like most natural material, is highly biodegradable. So working with bamboo means working within the limits of nature in the capacity of Earth's ecosystems and the ability to produce natural resources. They form a renewable resource and are harmless when they are disposed and disintegrate over time. And bamboo has the ability to sequester large amounts of carbon, especially in a well-managed plantation where harvesting is done properly and regularly. And bamboo plantations are actually easy to manage because it grows very quickly compared to timber. It's self-replenishing, so new plantings are not required after harvest because the root systems are still intact. And the other important thing about bamboo is that it grows remarkably quickly. So it grows to full mass within 6 months, and it's suitable for structural use within 3 to 5 years. So you compare that to hardwood trees, which take around 30 to 50 years or even longer until harvest time. So it means that investing in bamboo for building materials involves a much smaller period of return on investment compared to timber. So, and then bamboo is also the ideal material in this concept of circular economy. So what is circular economy? Circular economy asks us to consider the entire life cycle of everything we produce, from cradle to grave or from cradle to cradle. So here on your screen is the circular economy diagram. So on the left-hand side, you get products which are 100% renewable, biodegradable after use. It can be either recycled, regrown by nature itself. On the right-hand side, you get the non-renewable industrial material whose finite stocks need to be secured by high-level recycling. So bamboo would work in this left-hand side circular economy diagram perfectly. So bamboo is often called the green steel for its remarkable strength. So the benefits of using bamboo in construction extends to the fact that it has high tensile strength, which is parallel to the kind of the fibers that run longitudinally along its length compared to most soft and hardwoods. So it's a very efficient building material because of its hollowness. This means that it's lightweight and it has high levels of stiffness based on its strength to weight ratio. So what you get when building bamboo is lightweight construction, which reduces perhaps the loads on foundations. But bamboo has its problems, and one of the greatest concern about using bamboo among many people is its durability. So being a natural material, it will decay. It's biodegradable. It is susceptible to insect attacks. So in the image on the left here, you see an infestation by powder post beetle, and on the right is a fungus attack. But there are ways to overcome by treating bamboo either naturally using traditional methods or chemical methods. So The object of treating bamboo is to remove the starch in the bamboo. The starch is attractive to insects. So bamboo with a starch content that are high would be very attractive to insects. So with traditional methods, you get various methods. For example, here, after harvesting, you just leave it in a river, soak it in the running water like river. And sometimes you could actually tie them up to make rafts so they can be transported to a place where they are required. So by the time these bamboo rafts arrive at their destination, the starch would have leached into the water. And there are also other traditional methods such as steeping, which is just leaving bamboo out to dry vertically, and smoking is also another good method, which is traditional. Chemical methods are means, of course, using chemicals to treat timber. In Malaysia, we use a lot of the open tank method, which is this, where there are big tanks, either in concrete or steel, where bamboo is immersed in a chemical solution, which is usually boron and borax mixture for up to 3 or sometimes a week. And or you can just put it vertically in a drum, the steeping solution. And there's this more effective method, which is the modified boucherie method, where pressure is used to push the chemical into the bamboo capillaries so that the starch comes out on the other end. And in Japan, you find the smoking method, where large kilns are being built to smoke bamboo. And then there's the vacuum method, which is used for treating timber, which also can be used to treat bamboo. So natural material like bamboo has always been used to build the environment in the form of vernacular structures in communities where the plant thrives, obviously. But we have lost that way of building. This is because of the Industrial Revolution in the 18th and 19th century, brought with it a shift from using renewable building materials to kind of non-renewable materials, which are mined, for example, such as iron to make steel for sand to make glass. So climate change and its devastating effects and the problem of waste has led us to kind of think about a more natural way of building. And I think there is a lot to learn from these vernacular structures based on this simple principle. These vernacular structures work and look the way they do because they are built for the climate and the site conditions, using what is available around them, designed for the culture and for the everyday life that people are living in them. So it is the same principle, I think, that could enrich architecture in contemporary developments without having to compromise modern aesthetics and technology. So still houses are still being built, mainly in rural areas. Here we have the Bahay Kubo or the Nipa hut in the Philippines. And this particular one on your screen is actually built by the Tiboli indigenous tribe in Mindanao, Philippines, where the columns, beams, and rafters and the walls and floors are made entirely out of bamboo. And they are mainly single volume house capable of accommodating up to 16 people at a time. And I find this, especially the window detailing is quite interesting, where it's hinged at the bottom. So when it opens up, the window opening shutters, it becomes a shelf during the day. And then there are these bamboo houses by the Mru people in the Chittagong Hill tracts in Bangladesh, which are still around today. So the main structure of this house is actually timber with their barks removed, but there is a secondary supporting members made entirely out of bamboo. The main columns and beams in this house is actually made from timber with their barks removed, and the secondary supporting structures are bamboo. So below the floor deck level, as you can see in the section of the Mru house, you see kind of props being used, which help to improve the stability of the sloping grounds and kind of counteract the lateral sliding that may be caused by mild earthquakes in this region. So they are, they've been proven to kind of be quite durable during earthquakes in the way that they are designed. So the walls of the Mru house are mat-like. They are woven bamboo. They're woven from 200 mm wide by 50 mm wide bamboo strips. You see the wider strips on the image on the left-hand side. The wider strips are vertical, and this makes sense because it is more effective in expelling rainwater from the surface if it's all more vertical than horizontal, so keeping it dry. The floor as well, as you can see, is a woven bamboo mat. And this is another very, very interesting bamboo structure, and it's actually built by the Chechen people, commonly known as the Dorza. It's a small ethnic group. They live in the Gamogofa zone in southern Ethiopia, and they are skilled weavers, which extends to their cloth making and also to their house construction. So these houses, we call them the Dorze houses, they are typically coned shape. They're about 5 to 6 meters in diameter, about 7 meters in height. And each house has a kind of a nose-like protrusion that protects the entrance, and there are usually no windows in this house. So the house, or this Dorze house, is actually woven like fabric. It consists of bamboo strips with their kind of the softer inside lining, inner lining removed so that they are able to be woven around, like the images shown here. It's woven to become this interesting conical shape. To waterproof this house, as you know, bamboo, when it's exposed to sun and rain, it doesn't last very long. So here there's an interesting solution to waterproofing the house. The final layer is a thatch that is made from bamboo sheaths. And what are bamboo sheaths? These are kind of the protective leaf that protects the nodes of the bamboo culms as it develops. And they're kind of like a dry, light leafy material, which are then taken off and then arranged like a thatch, as you can see on the image on the right, being made into a thatch to protect the bamboo Dorze house. So research shows that this Dorze house, if maintained and built well, can last 40 to 50 years. Another interesting vernacular bamboo technology is this wattle and door wall construction. This technique is commonly found in Central America and South America. It is locally known as the Baharek or the Quincha system. So it's widely used using the Guadua angustifolia, because Guadua bamboo grows very well in this part of the world. So it consists of like a woven, a frame and woven bamboo strips, and then it is plastered, and it's usually a plaster with a mixture of mud and horse dung. So, but later now it's mainly changed to clay or concrete. So properly built and frequently maintained, the Baharek has good structural properties that can resist damage from earthquake experienced in this part of the world. So the Baharek has been used in contemporary architecture. So this is a house with a wattle and door modern construction in a project by Rama Studio in Ecuador called the Casa Lasso. So another important vernacular tradition is the bamboo scaffolding, which I'm sure everyone has seen before in Hong Kong and South China. It is a tradition that goes back hundreds of years, where it was initially used to create temporary Cantonese opera theatres and worshipping halls, but now you see them being used to create high-rise towers. The scaffolding system is very, very simple, but makes sense and easy to create. It effectively uses ties and anchors to create these three-dimensional climbing structures. And the bamboo use local bamboo. They're called locally kaoju and maoju. The kaoju being the famous moso bamboo that is grown in China and Taiwan quite a lot. So the most bamboo buildings that you see being built today, they are built using a vernacular-based methods of construction and jointing. Yeah. This traditional method usually involves kind of making unique cuts to increase the contact surfaces between them. And then lashings are often used to keep them together. So the rigidity of this traditional joint relies heavily on the friction between calms, between lashings and the calms, and the tightness of the lashings. So this approach produces some of the most elegant connection details and some of the most beautiful bamboo buildings, as you can see around you, but they are labor intensive and they rely heavily on a worker's skill. Nevertheless, it's an important technique that we should all need to understand in order to develop more modern methods of jointing bamboo. So we've done a few bamboo projects, not many, but they are mainly built using this traditional jointing method. As you can see in these images on the right-hand side, they are cut and then fit together and then lashed using strings, and then we've also applied resin to the strings so that they don't unravel. And this is another project of ours, which is the bamboo classroom in Camarines Sur in Philippines. Again, it uses a traditional jointing method, but here we've added nuts and bolts. Because this is a wind resilient structure, it needs a certain high degree of rigidity for it to withstand or to resist the wind. So it's kind of a hybrid between a traditional technique and, well, I wouldn't say it's modern technology, but kind of an intervention that involves modern materials. So you can actually create very modern and contemporary structures using traditional technique. Here, simple lashings again are used to put together a simple pavilion that we've created for the World Urban Forum in 2018, and simple bamboo rings with some of them inserted with colors. This is designed for the UN habitat, so the colors reflect the sustainable design goal colors. So again, using very simple connection technique. This is another interesting project in the way that it is made. And this is the Forest Pavilion by N Architects, who are based in Brooklyn, but the building is in Taiwan. So this kind of interesting diaphanous curving structure is actually built by 20 mm diameter bamboo. It's local bamboo that grows quite a lot in Taiwan. It's the Makino or the Philostachys makinoi bamboo. So they are almost solid, like rattan. So it acts a bit like rattan. And the image on the right, seeing you see the bamboo structure being just put up, and you can see that the bamboo is green. So the bamboo that are used are small in diameter and they are freshly cut, which allows them to be bent by hand very easily. And then they are secured using stainless steel wires. So this is one technique to create kind of interesting curving shapes with bamboo, using small bamboo and using it freshly cut. So using vernacular methods of construction is capable of producing some of the most amazing bamboo architecture. And this is the bamboo sports hall for the Panyayaden International School in Chiang Mai by Chiang Mai Life Construction. And you can see image on the right-hand side is the traditional techniques used to put it together. So traditional methods of jointing round bamboo culms involving friction, tight lashings, and pin and socket connections remain a vernacular practice. It is craft-based, it's custom-made, with the quality and strength of connection dependent largely on the skill and workmanship of the worker rather than precise mechanical calculations. So it works remarkably well in small projects or one-off buildings, but applying such practice to large development can be impractical. It can add significantly to construction time and costs. So for bamboo to be used as a modern building material, it needs to be, I believe, modernized, industrialized, so that they will allow flexibility, easy and quick assembly, in addition to prefabrication and modularization. So there are many examples, there are lots of research being done on modern connections using different materials such as timber, PVC, metal, sometimes resin. And these techniques allow for the connecting of bamboo in different directions and for allowing bamboos to be grouped together to become columns and beams. So it's not impossible. So a lot of research has been done. So one of the most amazing, perhaps one of the most beautifully detailed kind of industrialized bamboo methods, bamboo building methods, is the energy efficient bamboo house by Studio Cardenas. So it's developed using dry connections. And here, what they've done is they've kind of tried to avoid perforating through the bamboo or infilling the bamboo with concrete. So what they've done is there's this lightweight aluminum plates that sandwich or clamp the bamboo together. And then they are tightened by the nuts and bolts that runs through the plates. So the structural integrity of the bamboo is not compromised by the drilling, which happens quite a lot in traditional bamboo construction. This is in China, by the way. So another more high-tech version, but this time using mortar to infill the ends of the bamboo culms, where they have set in kind of a steel connector piece to the end. So what happens is that the steel connectors that protrudes out of the bamboo is able to be connected in many different ways. So this kind of solves the problem of non-uniformity between the culm dimensions. It's kind of making the ends of bamboo culms uniform. Yeah. So this is another interesting development in kind of industrialized modern bamboo construction. Here's a very recent tensegrity structure by Project Bunny Rabbit in London. It's where they've developed a special end cap detail allowing steel wires to be threaded through. And this allows the columns to be kind of amazingly hoisted up in the air in a fashion that seems to defy gravity. So this, again, another end cap detailing that could be developed for your competition project. So I've said this before in this lecture that for bamboo to be used in modern building material, for use as a modern building material in mass developments, for example, like housing, it needs to be modernized, it needs to be industrialized, as it would allow for flexibility, it would allow for easy and quick assembly of structures, and also prefabrication and modularization. So my office is currently looking at developing connection details for a kind of a proposed bamboo terrace home. This is a self-initiated project which allow bamboo culms to be connected quickly and easily on-site or off-site. And it's based on a system that has been used in the scaffolding system. So what we're aiming at is to come up with housing that uses bamboo that will appeal to almost everyone, to bring the idea of bamboo house or bamboo building beyond kind of resorts or rural developments. So to achieve this, bamboo needs to be seen as a standard modern building material that could easily be obtained in the market and it passes all the building codes. So I'll not talk about building codes today, but currently it's not really acceptable to build structurally out of bamboo in terms of local authority approvals. So one of the reasons that stops bamboo culms from being successful as a building material, it's dimensional instability. You would not find two bamboo culms that are exactly the same size. They are not perfect circles as well. They are always bent. It's very hard to find bamboo that is very straight. And they're also conical, which means they are smaller at the bottom, bigger at the bottom and smaller at the top. So this makes using bamboo as a building construction very difficult. So to overcome this, there are these kind of remarkable developments, particularly in China, producing engineered bamboo sections. And they are sometimes known as the LBLs, which stands for laminated bamboo lumber. They look very much like timber. In fact, they have lost their bamboo look, but they are capable of acting as structure, as cladding, and also as flooring and many other different uses that you would expect from timber, perhaps. However, the energy required to turn them into something easy and familiar to use may or may not compromise their sustainability credentials. Which is why I'm leaning more towards whole bamboo culms in architecture and building construction. There are many companies that are developing these bamboo laminates. One of them is by Renutech in the US, which uses South American guadua bamboo to make structural engineered bamboo, which they claim you can use to build high-rise bamboo buildings. Of course, there is the Moso bamboo, a popular, a famous company name that produces this bamboo range called the Bamboo Infinity that could be used structurally. Here you see it being used to build a little shed and also as cladding inside an office. So this is the end of my lecture. It's a bit short, but as an end note, I would like to say that bamboo in whatever form is a very sustainable material. But to make it truly sustainable, we need to be careful about the embodied carbon in their making. Meaning the energy and carbon emissions required in their planting, in their harvesting, in their transporting needs to be considered. Also, we need to be careful of the impact to the environment. For example, the leaching of chemicals into our environment and into our water, and also problems of deforestation. So to make it truly sustainable, we need to consider all these things to have a significant influence on their true sustainable value. But saying all that, bamboo remains a much more sustainable material compared to others like concrete, steel and glass. So that's it from me today. I hope there are lots of questions, and I would like to wish all the students good luck with the competition. Thank you.
Okay, thank you, Dr. Eleena, for a very informative and knowledge-packed talk. We are certainly very inspired learning about the potentials of bamboo and also some of the things concerning the sustainability aspects. So we shall now open the floor for questions or any comments from the participants. So if you have any questions or comments, you can just I think admin, they can switch on, can they turn on their mic? If not, then we can also allow you to raise your hand and then you can unmute your mic from our side.
Hello.
Hello. Introduce yourself before.
Okay, my name is Dr. Wan. I'm from FRIM, Forest Research Institute, Malaysia. And can you elaborate more on the competition? Because I heard architect Eleena said something about student competition. Because maybe I can contribute something. I don't know.
All right. This competition, without having the, immediately I can have the documents to refer to. This is the Utah and PAM is working together to organize the national level competition. So the winners of this competition is a competition for bamboo design and construction. It's open to all private and public universities, tertiary education level. So the competition was launched last week and now is still ongoing, open for registration. I think the registration is until end of July, right? And maybe what I can ask my colleague, Mr. Muluk, to post, to share the information of PDF file on the chat room here so that you can refer to. So the competition, the winners, the two winners from the Malaysian level will represent Malaysia to participate at the international level. A competition initiated by Guangdong, Macau area and Hong Kong, and together with ASEAN International Bamboo Construction Competition. So the winners will represent at the international level, and then the winners from the international level will get their structures to be built in Nansha Bird Park. Yeah, so this has been held for a number of years. And for Malaysia, we started to participate in this competition since last year. Yeah. Yeah, maybe we can share the further details on the guidelines, the criteria, and the submission details here, the chat here.
Thank you. Thank you very much.
Yeah, we can also get your email and then we can email you the competition. Muluk, is there anything that you want to add on this?
Dr. Wan, you can email the email that I've shared on the chat for more information on the competition.
Okay. I'm doing it now.
All right. We have other questions or requests or comments?
I have a question.
Rahimi.
Sorry.
Hello.
Yeah, hi.
Good afternoon. My name is Rahimi. I'm part 1 graduate from IIUM. I have one question actually. Eleena, is it possible to see Malaysia having bamboo as an alternative sustainable material in the near future?
Can I just stop you for a while?
Okay.
Somebody's mic has to be turned off so that we can hear better.
I think the sound comes from Rahimi.
All right. Okay, Rahimi, please continue.
Okay. I repeat my question. Is it possible to see Malaysia having bamboo as an alternative sustainable material in the near future, as opposed to brick and also concrete? And is it allowable by the authority and also the firefighting department?
The fire safety aspects?
Yeah. Right now, I think it is still a long way to go before it can be a modern building material, which is at the same level as concrete, steel, or glass. Because I think there are many hurdles that needs to be addressed. There are many issues that needs to be addressed before it can be a standard building material. For example, there's so many species that are available in Malaysia. So there is a need to be for a real study on which species are the best for building construction or for it to be used structurally. There's also building codes right now. I think it's very difficult to get approvals for a bamboo building, especially if the bamboo is used structurally from Bomba and from the local authority, because it it doesn't exist in our building bylaws and regulations. Also, I think the treatment methods as well needs standardization. There, in my talk, I mentioned quite a number of different methods of treating bamboo. So it is very important that we kind of standardize the way that bamboo is treated. So I guess it needs to go through all the process as timber had. Timber had a very clear kind of set of adherence to local codes and very clear methods of treating, clear methods of selection, things like that. So it's still a long way to go. So it's a very new material in the country, but we see a lot of resurgence of interest in bamboo, a lot of awareness of its credentials as a building material. So I think it's moving in the right direction.
I see. Thank you, Dr. Eleena.
Thank you.
All right, we have someone raising a hand, and we also have someone type the question here. We shall look at the question from the chat room here, from Irene Chan. She was asking, as Dr. Eleena said, it's prone to sun and water, so for modern building material, will it be treated on the surface to increase the sustainability as we are used to it in Malaysia? Doctor, do you like to take the question?
Hold on, my printer is running, so it's a bit of a noise. Hold on a second. Yes, I think for it to be used in any country, really, it needs to be treated. We've seen bamboo being used in Europe for a car park structure, and after a few years, even in different climates, there is evidence of decay, mainly because it's not protected from the sun and the rain and the elements. So yes, definitely it would need protection, which is a shame really. But there are ways to design in a way that would allow bamboo to last longer, and that way is to use it internally. Even if you use it as a structure, it's best to use it internally, to put the structure internally rather than externally. So that would lengthen the life of the bamboo considerably.
Right. We move on to the next question from Lionel. Lionel, you raised your hand just now, so you may ask now.
Hi, can you hear me?
Yes, we can hear you.
Okay. So my question, well, I really like your talk, and then you were talking about in the beginning about bamboo being a sustainable material and talking about cradle to cradle, and I kind of wanted to pick your brain on that. Like, in terms of bamboo being a renewable material, can it be after its life cycle? Can it actually be used as something else? Because after rotting and stuff like that, I know that it kind of becomes like cradle to grave. But how can it be in a way renewed as in the cycle of cradle to cradle in a way?
That's an interesting question, because bamboo are mainly discarded because it has started to rot, or it's eaten by insect. So what happens is it is actually discarded. It biodegrades. But I think when it comes to, for example, bamboo laminates, they are actually reusable for a long time because they have been treated with technology. So the treatment methods are quite high tech. So when it comes to bamboo laminates or bamboo flooring, they could actually be reused as in other forms after their service life.
I see. After bamboo rots and all that, can it be served in some sort of like I don't know, maybe some kind of infill or like a source of fuel or whatever method, like is there some sort of exploration of the cradle to cradle aspect of a material.
Yeah.
So it's like kind of extending the life of the materiality of the material itself.
Yeah, I think when we use bamboo as in the form of round cones, it will end up, being discarded and biodegrade. But I think we have to be careful about the chemicals that are used to treat bamboo, because as it biodegrades, the chemicals will start to leach into the environment. So that's another issue I think that's worth thinking about. So it would be best if that bamboo can be developed in a way, or bamboo technology can be developed that we can actually recycle it to use it in a different way, maybe not structurally, but use it to make household products perhaps. And you find there is a company in, I'm not sure where, but they've actually taken, bamboo bamboo chopsticks. Yeah, because there are lots of people, restaurants use bamboo chopsticks, and they have been changed. They have been collected by this company and then used. They use the bamboo chopsticks to make furniture or to make other household items. So that's one way of kind of recycling bamboo elements. So I don't think it's an impossibility. It's better to recycle than let it biodegrade into the ground.
Thank you.
Thank you.
Right. We have another question from Renzi Irvin. I can't see the name clearly. He's asking, can you share any information on utilizing bamboo as a structure member like rebars, piles, etc.?
I'm afraid I am not an expert in using bamboo in that way as reinforcement for concrete. But I believe there's a talk in this talk series where one of them is an engineer, one or two of them is an engineer, who will address the use of structural bamboo as rebars or piles. But I know there is research in ETH Zurich, Singapore, who actually do amazing research on using concrete reinforced with bamboo quite effectively. So maybe you would want to look that up.
Yeah, don't worry. We have series of talks over the next 6 to 7 weeks on various topics, including the construction method and also different aspects of bamboo design and construction. So you may want to check out on that. We will share the poster afterwards. Okay, there are some more comments on the chat room. Abdul Rahim, to everyone. He's saying, we are currently planting in mass scale of Diodocalamus asper betung under clarity crest, Sendirmerhat, and will be matured in 2024 onwards. And this will provide some source of bamboo and bamboo material to the market. So this one is a comment from Abdul Hamid. And then we have from Guma Sylvester. In your opinion, what do you see is the biggest challenge for bamboo to be widely accepted and adopted in terms of use in general construction in Malaysia? Dr. Eleena?
I think the main challenge is trying to change how people perceive bamboo. Bamboo buildings tend to be rustic. It's sometimes seen as poor man's timber. So perhaps it doesn't reflect the look or the design of a certain look that a developer is looking for. So that is kind of the main hurdle of people accepting bamboo. But that's why I was saying that we need to industrialize bamboo to move it towards prefabrication, industrialization, for it to be accepted as a building material.
All right, we have someone here, some more questions. Okay, from Mustafa Nasuha. Can I know what's the best way of possible right now to increase bamboo lifespan?
Yeah, the simplest way, of course, is to keep it out of the sun and rain. That's number one. And for treatment to be carried out efficiently, which is why we need a kind of standard way of treating bamboo where we can evaluate, where we can check that bamboo treatment is actually done the right way. And that's the problem right now. When you buy bamboo, I think in this country, you don't really know how well the bamboo is treated. So number one is to keep it out of the sun and the rain, and the other is to make sure that it's treated effectively. And I think it would last, for a considerable amount of time.
Okay, is there any other questions from anyone? Okay, in Malaysia from, okay, just now I missed the message here. In Malaysia, what are the species of bamboo available at the moment, especially for construction or building material? How vastly available is this resource currently? Maybe in conjunction with this question, so we can also interested like where to buy them and around how much it costs.
Yeah, there are many species. Bamboo, as you know, thrives in Malaysia. There are at least 50 indigenous species that grows in Malaysia. Of course, not all are suitable for construction. In our Bamboo Playhouse, we use the Dendrocalamus asper, which I'm not mistaken is buluh betong, and then buluh akar as well. And also the Scortacini, which is, I can't remember the local name for it, but there are a number of species, I think 5 to 6 species that are very suitable for construction. Another one is buluh duri, the Bambusa blumania, which we have in this country, but very hard to find because not many people are really planting them. They are perhaps the best and the strongest bamboo for construction. So there is really nothing stopping us from using bamboo as a building material.
Okay, there are more questions here. I'd like to know if lifespan, other than the lifespan, if it is pre-treated, is there any chemical fumes used during the treatment released to the environment? From this one is a message from Radin Fikri. I think this message comes from the Facebook Live.
Yeah. Bamboo and timber used to be treated by CCA, which is a copper, chromium, arsenic. So that was very dangerous to people because it releases fume, and when it's discarded, the arsenic released into the environment. But now I think there's a shift now from using more safer chemicals for treating bamboo. For example, the boron and borax is quite safe, relatively safe, but still I think it can be improved and more R&D and more research can be done into looking for ways to treat bamboo, to make sure that it's a truly sustainable material that is not dangerous to the environment. Did I answer that question right? Or? Dr. Lim, you are...
Dr. Lim, you're muted.
All right.
You're
Okay,
muted.
sorry. Okay, from Visha saying, how best can we start using bamboo for mass scale, for bus stops or public toilets?
I think we can start using bamboo now because they are quite small projects, and for bus stops and public toilets, they are quite small open buildings, and I think there's nothing stopping us using them. But then when it comes to mass developments like housing, then we have to start thinking about industrializing, modernizing bamboo for it to be used in such kind of developments.
Yeah, I think some more question on the cost. This one from Irene Chan. She's asking like, do you agree that it's going to be costly for labor as it is a skilled labor intense construction and probably we can't find one in Malaysia? As from my experience, comparing the labor costs and also the material costs of bamboo structures or construction.
Yeah, bamboo structure are
is
very labor intensive.
Comparison? Yeah.
Yeah, bamboo structure are very labor intensive, mainly because they are, as I've said in my lecture, they are vernacular based techniques of putting together bamboo. So it relies very much on the skill of the worker, and the strength of the connections also relies on how well the connections are made. So I would say that it would be labor intensive. And again, if we are to look at applying it to mass developments, then it needs to be industrialized to kind of standardize the way that the bamboo elements are put together in a building.
Yeah, there are several questions here. Some of them are from the Facebook. From Sarah Rahman, would you suggest using bamboo as a whole, as a structure, joineries and surface to enhance its durability? Or would you suggest combining construction of bamboo with different materials, for example, using concrete steel for the joineries?
I think we will never get rid of concrete, steel, glass, bricks in construction. It would always be there. It is a very highly developed, easy to use material. So I'm not suggesting that bamboo replaces all these modern materials, but it can coexist as an alternative, to give us a choice of how it may be used. So I am very interested in combining kind of modern contemporary materials with bamboo. I think that is a move in the right direction as well, in order to maintain a kind of encourage the acceptance of the material. It doesn't have to be all 100% bamboo. That, you know, having a choice, for example, the cladding to be made out of bamboo rather than something else, but the structure could be maintained as concrete or steel, and that is a move in the right direction, in my opinion.
Yeah, there are several more questions, and then one question is on comparing the potentials of timber and bamboo. Maybe you explain in your slides, and maybe you can just, just highlight the
Sorry, what's the
comparison.
question again?
Comparing timber and bamboo as a material.
Yeah, timber is very easy to use. You don't use timber as logs to build buildings. But what we are trying to do is to use bamboo in its natural form, which is this round culms, which becomes very difficult. With timber, it actually goes through a process of cutting and planing to make it a standard building material. There is a 2x2, 3x3 timber, so which you can easily buy at the lumber's yard. But with bamboo, you are actually chopping it down. You are accepting all the dimensional instability of bamboo, the different kind of, all the ununiformity of bamboo, and trying to use it like a standard building material. So that's the big difference in using timber and bamboo. And of course, timber is a very developed building material. It has all the necessary certification. It is accepted by the local authority when using it as structure, and it's also accepted in terms of how it is treated. So the treatment quality is assured with timber, whereas not so much with bamboo.
Yeah, that's from Dr. Wan from FRIN. I think Dr. Wan has a message here. It's not a question. FRIN has invented or patent pending a bamboo post connector that requires no further shaving or drilling of the post. The connector code name Bamboo NX tall allows for diametrical size and shape inconsistency to some practical extent. So Dr. Wan's phone number is here. Anyone is interested in this can contact him. Okay, is there any further questions? You may raise your hand and turn on your mic. Yeah, looks like a lot of questions. Yeah, and okay, there's a last one from Shen. What is the challenge of bamboo becoming mainstream building material?
Yeah, I think same as my response to the earlier question, that there are problems about finding the right species, the treatment needs to be standardized, it needs to go through enough research and development to be approved as fire resistant structure as well. So all those kind of things, all those things that timber has gone through to make it a sustainable, an acceptable building material needs to be applied to bamboo. There's one question which I think is quite interesting by Yi Chong Wong. Based on your experience, do you think bamboo buildings provide any therapeutic and healing functions to the occupants compared to conventional buildings? I'm not entirely sure, but I think natural materials, I think, do provide some sort of, calmness to. It makes you feel like you are rooted to the environment, not just bamboo, timber, rattan, and all those natural materials. I think that's an interesting thing. I think it deserves a research on its own. But I do think that it does have some effect on your well-being. Thank you.
Right. It seems that that's the last question from our audience. Perhaps if I might just ask one question. From your opinion, since you're very much into research-led, so for bamboo, if you can name one research area that we should embark on, what would it be?
One research area. I think when it comes to bamboo design and structural design and how bamboo is connected together, I think that's well covered by a lot of other people. And I think treatment of bamboo, I think, is a worthwhile research area that really needs attention. To really make bamboo as a modern building material, we need to get the treatment right and the treatment standardized, and some sort of an accreditation to bamboo treatment. I think it's worth doing if we want to see bamboo being developed as a modern material.
All right, thank you so much for the wonderful sharing and very informative. I think it created a lot of interest in us on bamboo and bamboo design as a whole. And just before we end, next week on the 21st of July, we also have another talk by IR Major Maslan on the topic on fundamentals of bamboo design and construction. So before we end, let us take a group picture together for record. So can everyone turn on your mic?
Turn on the camera, not mic.
Turn on the camera, sorry. So let us take a group picture. Everyone please turn on your video. Turn on your video, turn on the camera. All right. Okay, smile to the camera. Turn on the video, please. Okay, thank you. Smile. 1, 2, 3. Yeah. Okay, more people turning on your video. All right. Okay. All right. Thank you very much. And thanks for spending time with us today. And thanks, Dr. Eleena, for giving us the pleasure of listening to you.
Thank you.
All right. So, all right. Bye, everyone, and see you next week in another session.
Thank you.